So this session, we're going to talk about use cases, right? I know we have some product announcement. There are other sessions later on today and tomorrow that you can learn about Edge Compute Stack. But today, we also have our partner and colleague from Siemens, Felix, right? It's going to talk about the use case, about the VPOC. Then we have Ben from Kyndryl that will talk about how do you prevent wind turbine from catching fire, right? And these are some of the hopefully interesting use cases, right? That can give you a perspective of what we believe the edge compute can do. Standard disclaimer, right? Don't roadmap, anything that is roadmap related can change, right? Standard disclaimer from us. All right, so before I start, can I get a show of hand? How many of you are responsible for edge compute for your business or enterprises? Keep your hands up. And if you're also responsible for data center and cloud. Okay? But for those of you that don't raise your hand, what are you guys doing? Like networking, security? All right. So I think it's important, right? Because edge, even though, there's a lot of buzzword about it, right? But if you already manage your data center and cloud, there's a lot of operational practice that you can actually borrow, right? And apply that tool at the edge. So what is new, right? What is different about edge compute, right? A lot of our customer ask me, hey, we run compute at the edge for a while, right? So what is new about edge compute? So the big difference had to do with the use cases, right? So compute at the edge is not new. Edge compute, because of the use cases that it can enable, drive more and more demand of computing at the edge. So if you look at an example like CCTV, right? How many of you guys have CCTV at your facilities, right? And for the most part, you store lots and lots of data, and hopefully you never have to go back and take a look at it, but you need it there because of if some accident happens, right? You go back and take a look at it. Some theft happens, you go back and take a look at the video. But what you can do now is you can actually analyze, right, the stream of data, like video feed, not only in real time, right, but maybe offline. But that drives a lot of compute demand. And especially with AI and ML becomes, I think, a lot more accessible, right, to us. That you can go and download model, right, from OpenVINO, from NVIDIA, and now you have a computer vision AI application that you can now run for your use cases. Anything from computer vision to do quality inspection, right, or to do predictive maintenance, or to do worker safety and so on, right? It's all rely on computing at the edge. And the use cases are going beyond just traditional IT applications. And then last but not the least, which Felix will get into more detail, right, is the digitization of the operation workload, right? So these are things that used to be physical devices, like the programmable logic controller, that we use it to actually manage process in the factory. Or something like protection and control that protect our house from kind of catching fire, right, because of overcurrent or the voltage, high voltage. And this can actually be digitalized and run as software on edge compute. And the one thing that, we have to be careful, right, as the business go out and embrace the use cases of, okay, I want to do worker safety, I want to do quality inspection. If you're not careful, you end up with lots and lots of hardware devices, right? Because you go and get the software, they say, okay, go run it on this operating system and go buy this hardware, right? And if you're not careful, you end up with the same situation we had with SaaS 5 to 10 years ago with Shadow IT, that you end up with all these different hardware devices at the edge that you may end up having to try to manage and upgrade and operate them at scale. So what we are trying to do, right, with VMware Edge Compute Stack is to give you an infrastructure, a distributed infrastructure that can be used to run, operate, right, and manage your application and infrastructure at scale. And to do that, we actually borrow sort of the playbook, right, that we believe it has been pretty successful in the data center, right, by giving you an abstraction layer that actually give you a platform that can run and operate the workload on different type of hardware, right, and let us take care of managing the life cycle of that hardware and managing the workloads, right, that you will need to run on this infrastructure. And to do that, we actually have a few components, right? This morning, we actually announced VMware Edge Cloud Orchestrator, right? That basically be the management plane that will manage and operate your distributed edge infrastructure at scale, right? I'm not going to get into the detail in this session because there's a session this afternoon, right? The keynote from our GM, Sanjay Upal, right? There's a couple more sessions. I have a QR code at the end if you're interested in learning more about the product, about what we are doing with VMware Edge Cloud Orchestration. Then on the runtime, right, there are multiple things that we are doing. One is we know, we realize that the infrastructure requirement at the edge is different. You may be running one node, right, or many of our customers do not go above like 3 to 4 nodes at the edge, even though if they want to cluster them together. Then the second part is be able to run virtual machines and container, right, together. Because we know even though the new applications like maybe computer vision, AI and ML will be developed as containerized applications, right? You may want to look into modernizing your applications, but still a lot of the workload is still VM, right, virtual machines. So need to be able to support and run both types of workloads. And then the last part is we talked about the operational workload before, right? So these have a pretty unique characteristics like low latency and real time. And if you work with our product in the past, like our hypervisor is very, very good at scheduling the workload to run on common resources, like CPU, like memory, right? It does a good job at that. But the real-time workload has a different need, right? When it needs access to the CPU, it needs access to the CPU, like it cannot wait. So what we have done is make sure that we can distinguish between the real-time workload and non-real-time workload, and then the scheduler doesn't get in the way of the real-time workload. And that's how we can deliver very close to the bare metal performance for those workloads that need it. So now, if we look at some example use cases, right, and these are just like, I think we're just scratching the surface, right? And you'll see some of this demo when you go see us at the expo, the show floor as well, right? In retail store, right, of course, like something as basic as virtual point of sales, right? And you can see that all this circle, we're just trying to show that it always interact with the physical devices, right, in some sort of way, right? In the retail store, I mean, you have the scanner, right? You have the camera that you may use to do like retail heat map or to do self-checkout and so on. Then when you go to like assembly line, it will interact with the robot cell, right? And we do that over Ethernet using industrial Ethernet protocol. Then the last one is like power substation, right? And this actually not only just the substation, but can be extended all the way to the distributed energy resources like wind turbine, for example, right? So we have, in this example, we have the merging unit, which is a device, right? Think of them as a sensor that collect the current and the voltage from the grid, convert that to a digital signal, send it over Ethernet, and now a software can actually process and operate on it. So with that, I'll get Felix to get out of his uncomfortable chair and hopefully talk to us about PLC.
my side, we will try the hand sign thing again at the beginning. So how many of you guys have already installed a VMware product before? Okay, nice majority. I don't know if I count that one in, but we will see. And how many of you guys have installed or engineered a PLC before? So that's a minority. I will try to take you on a journey of people who try to do both, because they see some kind of advantages out of this, and they need to do both to achieve or to solve these. My name is Felix, I'm from Siemens, and before I will start doing the presentation and stop you guys from doing it, how many of you guys know Siemens? Okay, so I don't need to do that introduction anymore. Well, before we go on this journey, I guess I need to talk a little bit about the challenges our customers are going through today. Some of them might probably be all known, especially the ones on the top row, right? Like volatile markets. You have to react to fast-changing market requirements. That's something that all of us have to go through, especially over the last couple of years, I guess. We have gained a lot of experience in that. We need to keep or improve our product quality. This definitely applies to any case of product that you have, while, of course, maintaining the same output. No matter if you're talking about software, if you're talking about manufacturing, if you're talking about retail, commercials in general, this always applies. And on the last thing, you have a lot more flexible product offerings. So you really get down to customized products, maybe even down to lot size 1 products that are really specialized. Now, if I'm start to talk more about the domain I'm coming from and go into digitalization, we are looking a lot into machine builders. And machine builders more and more start to have their actual IP in software development. While decades ago, you might do or build a very, very good machine by just putting physical pieces together, the actual value add starts to become more and more into software. So you need to do more software development. This is also a very challenging momentum for these kind of customers as well, because they are not really experienced in this field, right? They used to do hardware. But they also need more IT technologies to actually enter this kind of a rising automation domain. And then the third pile on the bottom, and that is something that we can see in the domain pretty much, is the lack of OT engineers. More and more engineers coming out of universities, of educational skills, they are experienced with IT technologies. I mean, just by every one of us having one of these in our pockets makes it quite interesting to get in touch with these technologies and kind of learning them a very natural way. So this is something that people are not used to, of going into more traditional or automation stuff anymore. They want to do the new, the cool stuff, right? They want to leverage the stuff they know from their first day they can start thinking of and want to do the same thing to automation domains. So we're talking about converging OT and IT technologies together. And how are we going to do that, or what do we need to look at, is something that can be seen over here, because this is like the different layers that we need to get through. So we start down there with field devices, sensors, motors, stuff that is close to the physical thing, right? Like really moving stuff, measuring stuff, knowing how hot it is, how cold it is. Going up to controllers, which is the main field where I'm coming from, looking into how to actually process this kind of information, maybe doing some closed loop controls, really reacting pretty fast on these topics. And from that point on, IT starts to get more and more interesting, because you start or you want to transfer these kind of data up to edge computing levels to really use geographically close compute infrastructures. You go up to manufacturing execution systems, even up to cloud, and then also more into app development, where you can actually start generating stuff that gets information, value out of the data that you have acquired from the shop floor. And the field that I want to talk about today especially is in this rectangle over here. So it's edge computing and controller. And this is something where we as Siemens have started to develop something new, which we call the virtual S7 PLC. So I don't know how much you are familiar with the PLCs, but I will also guide you through that stuff a little bit as well. And this is something that we have announced at the Hannover Fair in Germany at the beginning of this year, and started or want to release it at the end of this year as an application that you can purchase via our industrial edge ecosystem. The question is, what is it, right? So a PLC today from Siemens is quite easy to understand. You have a hardware device, you have the PLC software stack on top, talking about a specific product. One of them is the S7-1500 PLC. You can order that, plug your actors, plug your sensors on top of this machine, and start to engineer your engineering or your automation program. Then you put that one, you deploy it to this embedded device, and your automation process can start run. That sounds quite easy. What we started to do is we took this PLC stack, we made it hardware independent, so you do not need to apply it to this specific hardware anymore. We also added some app management over IT and edge technologies, which we have in our entire industrial edge ecosystem, and made this a virtual SIMATIC S7-1500 PLC. So you are still, as a customer of today, familiar with the same technologies. You can still leverage the stuff that you know. You can even use the programs where your IP might be in, put that one on this virtual PLC. So at the end, this is an edge application, and maybe more from an architectural or technology side, as you can see on the right-hand side. We start to run this on an industrial real-time Linux, taking the Docker or container technology, putting the software stack inside, wrapping it around, packaging it so you can also easily deploy it and do the entire application lifecycle management through our edge technologies. Now there's an important keyword on this slide. It says real-time. And real-time is something that can be highly misunderstood if you start talking about real-time with IT people. And I think Kangwarn and myself had many discussions about this before, so I would like to introduce another term on this, which is more time-deterministic behavior. And also, a funny discussion we had many times is, yeah guys, we understand time-deterministic behavior, you need some reaction times, but how low do they need to be? And the answer from our side at that point is, it doesn't matter how low they are, they need to be stable. The use case defines how low they need to be. Because all of you guys probably know a traffic light, and it doesn't matter if a traffic light gets green 10 or 15 milliseconds later or sooner, but if you start filling a Coke bottle and you try to stop the valve in the right moment in time, and this is 10 milliseconds too late, none of us have ever seen Coke bottles with different levels of Coke in there, right? All of them are quite a straight line. This is where time-deterministic behavior gets very important. And this is something where, over the past, virtualization technologies, as we know them from data centers and so on, did not go into this field because it also costs some kind of performance. Usually you try to consolidate and not try to put time-deterministic behavior on top, which usually takes 100% of your resources to some sort. But how can this be achieved today? And that's something where we got in really close discussions also with the VMware Edge Compute Stack to leverage this technology, leverage what Kangwarn and his team put inside of this. And they started to enable something where we can get into the direction of time-deterministic behavior, into time-deterministic control, and therefore start using PLC technology on top of a hypervisor, and therefore consolidate workloads to some sort, manage them very good, just increasing the efficiency overall on using this kind of technology. Besides that, if you wanted to put additional virtual machines on the site, or for example, having also access to the engineering, which is done by something we call the TIA portal, you can also place these virtual machines right down there. You don't need to run them all the time, but whenever you want to get an access directly to the version that you used for engineering this PLC, you can just spin up that virtual machine and do not need to look for, and this might sound crazy, for the laptop that is somewhere in the shelf having this version installed. Unfortunately, that's the reality how it works today in many cases. I see nodding heads, so yeah, I guess you guys know what I'm talking about. Additionally to that, there is something on here which is called the Industrial Edge Management System. So this is our central remote management platform where you can then start accessing or doing lifecycle management of the application, not only the application, also the virtual devices, also all other applications like HMI applications or other edge apps that you put on top of there. So you have the possibility to do this also across your entire plant and get it really down to devices you have right besides your sensors. You don't want to get into physical contact every time that you need to update something. So this is really leveraging IT technology, trying to bring both of that to our automation customers. At the end, it comes all down to the question, what's in for me? What's in for me as a customer? What is my customer value? And there's many of them, right? I mean, first of all, IT meets OT. It's openness to a third-party application. It's something where many people talk about, but then have the possibility to actually start it. It is the availability and the reduction of maintenance efforts. So you can do many things remotely. You can try many things out. You can start with a virtual instance, just trying to get it somewhere before you actually apply it to the real process. You can clone instances, so you can leverage all the things that you know, or that, well, that's kind of wrong, because that IT guys know from IT technologies and apply them to an automation field. It sounds like a dream. Sometimes there is a minor but. Because of this time deterministic behavior, it's not that easy to just apply everything. Fault tolerance is something that we started to talk about as well. So as soon as you talk about time deterministic cycles, of course, it's quite difficult to say, hey, I do have a second instance over here, it takes over directly. This is not happening in the microseconds that it needs to happen, and it's not guaranteed. So there is certain challenges which we, of course, still have to solve, but this journey has just begun, so there is still a lot of time to do so. And I promised to talk about some use cases. So there's actually many customers already in contact with us doing that stuff. And I brought two of these use cases with me. The left side is more of the machine building use case and applies directly what I've just said before. So we are in contact with machine builders that want to get rid of getting in touch with the machine itself physically. All the time they want to adopt, all the time they want to change something. So their biggest value is in remote administration. They have the possibility to access the program, to access the PLC, but also every other program that they have on this machine, a remote way to get the current states, to also apply updates, to just clone the machine, apply it to a simulation environment and see how it behaves or what is happening. On the right-hand side, we have a German car manufacturer which is in contact with us on applying VPLC to the manufacturing sites, to multiple processes where they have usually PLCs which they want to use to, or which they want to convert over to VPLCs to some sort, and leverage from especially the consolidation cases, leverage from the remote accessibility, and also putting a lot of non-real-time workloads on top. So they really try to focus on not having too much compute infrastructure at their shop floors anymore, because it's a whole other environment where they need to get there by their feet anytime they want to change or adopt something. So they really see a huge benefit in how they will handle automation in this kind of environments in the future, and also have the flexibility to, first of all, scale them out, but secondly, also add something over time that might bring additional value without needing to stop or even change the entire line. With that being said, I'm at the end of my part, and I guess I will hand over to Ben from Kyndryl.
Thank you very much. Yeah, thanks everyone. Can you hear me? Hello? Okay. I am Ben Brillat. I'm a distinguished engineer from Kyndryl. And Kangwarn said at the beginning that this is a session where we're here to talk to you about use cases. And one of the things that we're looking to edge computing to do is to enable use cases that would have been previously impossible, right? What can we do in the world that we simply couldn't do before? So I'm going to show you an innovation project, pure innovation project that we've been working on together with VMware and Bucknell University to talk about using edge computing in wind energy production. So why are we looking at wind, right? I'm not an expert in wind, but we're trying to talk again about use cases that are new, things that we think the world needs that we can accomplish because we have edge computing. And wind energy is absolutely a fast-growing and critical part of our energy production. Just in the USA alone, between 2010 and 2022, we've grown from 10,000 wind turbines to 72,000 plus turbines. They are becoming a critical part of our energy production infrastructure, but maintenance is very expensive, somewhere in the vicinity of $45,000 per year per turbine. But failures are catastrophic. Fire is among one of the leading causes of failures at turbines. The odds of a turbine having fire over its lifespan are about 1%, and it leads to total loss of the turbine in 90% of the cases. So you're talking 0.9% of turbines seeing failure in their lifetime that involves catastrophic failure from fire. So this is, of course, not good, right? You want these to be out producing energy. And the consequences are significant. When they catch fire, you're having knock-on environmental impacts. That entire power station might have to be taken offline, hundreds of turbines. And we've identified that there are 3 components in the turbine, the brake, the transformer, and the converter cabinet, that are likely to have fire. But of course you could look for a fire with a heat detector, a fire alarm, but that's just telling you that it's happening, and then you've lost the system already. It's a loss, and you have to move on. So what we want to do is we want to use edge computing to help us move from being reactive to predictive. We want to catch major failures before they happen and save the equipment. If you see on this chart, the earliest possible detection of the failure may be some years away. But if you can move into the area of using vibration or using thermal or using temperature to detect a possible failure, you've moved the maintenance window into weeks or months that you have to resolve a problem before you've lost the system. So this condition-based maintenance of I'm going to wait until the turbine has 10 million RPMs and then I'm going to do it, doesn't necessarily catch that there was some earlier problem, a problem that you want to identify before the system fails. So why is edge computing useful for this? Well, like I said, we're trying to enable net new use cases that were previously impossible. And the use case that we have worked around is using machine vision, AI/ML model, to identify abnormal thermal profiles in the nacelle housing of a wind turbine. So again, not being an expert in turbine manufacturing, what we can say is that we can use machine learning, we can use computer vision to take a thermal camera, put it in that nacelle housing, and aim it at all of the 3 likely components that where fires start. If you can identify a thermal deviation from the normal, then you can call a maintenance technician who can go and see why is this component doing something thermally that it doesn't usually do. And this is an important difference because previously, of course, there are sensors. There are absolutely point sensors. You can put a point sensor on each device. You can put a thermistor on the device and measure temperature, or you can measure the vibration. But by using a camera, we're now capturing that entire component, right? What if you had the thermistor here, but the thing that was getting hot was just here, right? 30 centimeters away. You've missed that opportunity for the failure detection, whereas with imaging, you're capturing the entire element. But now that I've decided I want to do this with imaging, now there are problems if I try to do it traditionally. So first of all, each camera may generate over 100 gigabytes of data per day. This is a lot of data, but what am I going to do with this data? Only a small portion of it, it may be 0 gigabytes of it on a given day actually relate to out of normal event. By inserting edge computing, I now have processing at the edge where I can minimize the data that is relevant and that I need to transfer back to a central site. I can move from hundreds of gigabytes maybe to far less than 1 gigabyte. Also the bandwidth. We're talking about, remember I said, use cases that were previously impossible. Modern Ultra HD video cameras can have streams of 25 megabits of more data transfer. If you think about an upload speed we're talking about from a remote mountaintop, which is where wind turbines are best, or far offshore, again, great places to put wind turbines. 25 megabits upload just by itself, one camera having constant every day in and out 25 megabits per second upload to the cloud to process that would be very difficult to obtain. Never mind if you had even just 20 cameras or hundreds of cameras. 20 cameras at that speed would be 500 megabits per second of upload data, which you just can't get in these kinds of locations. So by implementing edge computing, now we can change our bandwidth profile and make this use case possible. Again, the connectivity, streaming video data, if we're analyzing this, we're looking for problems that are happening at any time of the day, right? Maybe it just got hot for 5 minutes and then it cooled back off. We need that data to be analyzed 24/7, 365, no exceptions, including when there was a storm or when the data transfer was down. By putting the compute in the turbine itself, we eliminate the need to even worry about the availability of the data transfer. And then finally, latency. We're talking about integrated cyber-physical systems of Industry 4.0, IT/OT integration. And if we're controlling these systems, we need the control point to have latency that is reliable, known, repeatable, and we can actually control the system. So again, this is addressing this big data problem that we have with IT/OT. By 2025, IDC estimates that there will be over 40 billion connected IoT devices generating 80 zettabytes, that's 80 billion terabytes of data per year in the world. This volume of data, we simply have to think of new ways of addressing it. We can't, Kangwarn mentioned at the beginning about the CCTV camera. We simply can't save all of that data. There just won't be enough disks and enough flash chips in the world to save all of that data. You have to be able to analyze it locally and move to a lower data profile where you're capturing and working on the data that really concerns your problem. So that's what I mean when we say net new use cases. So what is this solution that we've innovated with VMware? I'm going to let some of the students from Bucknell University give a little intro to what we've been working on.
Hi, my name's Hank Bethel, and I'm the project manager for the Kyndryl Senior Design Team. Today we're excited to present our Energy Site Edge Computing System, equipped with a machine learning model running on VMware ESXi. Our unique design offers a remarkable range of features and capabilities. This model's core function is to do local processing of information at the edge. We demonstrate this with an RTSP stream, analyze it using machine learning algorithms, and control the turbine's operations, all without the need for stable internet connection. This makes it an ideal solution for remote locations and areas with limited connectivity. One of the key strengths of our system lies in the scalability by using containers on VMware at the device edge. This flexibility allows us to seamlessly integrate new sensors and machine learning models as needed. As a result, our wind turbine model can be easily adapted and upgraded to meet evolving demands and requirements.
I'm Henry, and I'm one of the design engineers on this project. I designed the physical model, and I'll be one of our members representing our team at Hannover Messe 2023 in Germany, the world's leading industrial technology trade show. Our advanced wind turbine model incorporates machine learning to analyze data, enabling us to detect objects within the camera's field of view, monitor motor vibrations, and uses an industry-ready thermal camera to not only monitor the temperature changes in key components, but also identify specific issues by analyzing heat patterns. These features could help optimize turbine performance, ensure safety, and minimize potential issues. This technology offers incredible potential for the renewable energy industry. Thank you for your time, and we hope you share in our excitement for this innovative solution.
All right, great. So thank you to Hank and team. The solution that you saw that we've created together with VMware is a microservices-based cloud-native architecture. We're using the same programming style, we're using the same concepts and systems that we would use in a cloud-native architecture, but we're bringing it, of course, to the edge. We're bringing it to the edge on VMware products. You'll hear more about them this evening. I think this is the product announcement. So that we can have a small, low-cost device that we can deploy sort of in fleets to wind turbines, deploy a standard model where we perform the key functions of the machine learning out at the edge. The connectivity from each of the containers at the edge is then back to the data center and cloud, but only for control, management, and gathering of the relevant data points. So we want to know that a system is out of tolerance. We don't need the actual video frame that said that the system was out of tolerance, right? Back at the central site. We're using VMware's infrastructure as a foundation. So again, this is a cloud-native architecture. It's completely software-defined, and we have that unified OEM that we're all used to from the VMware Cloud Orchestration Suite. Finally, the other thing that's important about this architecture is that it is stateless and each element is decoupled. This means that we're managing computing and we're managing software resources kind of in the same way that we would manage a Wi-Fi access point in this facility, right? The individual Wi-Fi access point or the individual edge computing node is itself completely replaceable. You know, we are able to push the state that we want onto that at runtime. We're able to trust that it will run and do its job, but in case that device should fail, it's immediately replaceable from the central orchestrator. This makes maintenance out in the field very easy. We don't need to sort of pre-stage and say, okay, technician, this is exactly the one that you need to replace it with. They can go in, they can replace the device. It will load the correct configuration for that, and you know, you're on your way. So, we're really looking to build an architecture, again, that enables net new use cases, that allows us to say we can do things and we can improve the longevity of systems, we can improve the availability of these systems in a way that you couldn't do before because we're using the capability that edge computing brings that you just didn't have available in the past. So thanks everyone very much. I've appreciated meeting you. Please, you know, look me up on LinkedIn if you'd like, and I'll hand it back to Kangwarn for some final comments.
All right. Thank you, Ben and Felix. So I think, just want to summarize, right? Hopefully we got the point across that the edge is different. I think for me as an IT person, as Felix would say, it's exciting because the things that both Ben and Felix talk about is basically IT technologies, right? Getting applied to a use cases that highly relevant to the business. And it's going to take a lot of, work, right, between the multiple teams to work together, right, and drive and develop new use cases. And we're not claiming to be an OT expert, right? That's why we're working with partner and ecosystem, right? We are providing a platform, right, that many of you guys are already familiar with, right? Similar technologies that you already know and use, right? And have done, use it in the data center, but now adjust it, right? And modify it so that it is applicable, right? Highly relevant to the use case at the edge. If you're interested in learning more, right, about edge compute, there are multiple sessions, right, that you can register or go back and re-listen to the recording. We also have a lot of exciting demo. And you're going to see more than just a monitor and a keyboard, right? So you're highly relevant to We cannot bring the whole factory, right? We bring a Lego factory into the expo, right? We have a robot arms with GitOps trying to actually play blackjack and hopefully win you guys some money, right? And then F-150 and then the retail store that you can just walk in, pick up the item, and then walk out, and we detect what item is missing. All right, thanks you all for coming. And I think we have some time as well for questions, right? We're gonna be around at least for 5-10 minutes, right? If you guys want to chat more, right? Let us know what you think, right? But otherwise, enjoy the rest of the show, and thank you so much for coming.